upskilling program. So this is different from a training program because we are here not to train people, but to guide or giving a second opinion as your partner in develop a safe heavy lifting. Nowadays, in this competitive business environment, safe is no longer the only requirement to be a winner in this industry. Efficiency should be taken into account. And to get a safe and efficient design, we should understand how the system works from practical and engineering point of view. Behind the best practice that we have until today, there are always explanation from engineering point of view. So this is a good combination between practical and engineering, and this is the reason why we built this upskilling program. So if any person who has no engineering background before can see the heavy lifting from a different perspective before decide the best practice that they want to use in their design. So yeah, that is the reason why we built this program. So I hope I could deliver this topic clearly to you so you could get a new and valuable insight from us for a safe and efficient lifting operation. And at the last of this program, tomorrow we will give you a capstone project. The purpose is not to judging you by giving a number or point to say you pass or not. The capstone project is some kind like to build a two-way communication between us, FDP, with US participant. If you have a problem with the project, you could discuss with us to find a best solution, not only to the capstone project, but also to the real case that you have. So that's the introduction from me. Before we are starting to this program, allow me to introduce myself. My name is Nelson Wiratno Panjaitan. I graduated from Civil Engineering Department of Institut Teknologi 10 November in Indonesia. I've been working as a construction methods engineer for 12 years, started from 2013. First time I joined with McDermott in Indonesia as a construction engineer. That was the first time I know about heavy lifting engineering. And I got so many insight about heavy lifting during my days in McDermott. And then in 2019, I left McDermott and joined Boself in Azerbaijan until now. So yeah, that's about me. I hope you will enjoy and get something valuable from this program. So in this program, we will discuss about crane stability. So basically, in crane stability, there are two main things that should be considered in designing a stable heavy lifting arrangement. First is stable based on the load capacity, and the second is stable in COG. COG here is not only about the structure or lifted object, but also all the item from the object to the cranes equipment like hook, boom, carrier, and then mast, crawler itself, and then counterweight, etc. So with this COG information, we will not only check the stability based on the tilting angle, but also we will estimate what is the ground bearing capacity pressure below the crane. So we now go to type of cranes. So basically there are two types of crane. They are mobile crane and static crane. As its name, mobile crane is a type of crane that can move from location to location. So generally, they have a bigger capacity than the static crane. Unlike the mobile crane, a static crane can only stay in one place. So basically, it cannot move. It only can slewing or rotating or changing the radius by boom up or down and moving the hook with its boogie. Now let's see what are cranes which include to mobile crane and static crane. First is a truck mounted crane. This type of crane usually used due to high mobility. For example, in the highway, uh, this crane equipped with some of this crane equipped with the outriggers, and the outriggers can be used if required to stabilize the contact point to the ground. And the reason of that is, as we know, one of the characteristic of rubber tire is elasticity, right? So when doing the lifting, the COG of the crane is not always exactly at the center. Sometimes it's offset at certain millimeters, for example. So this offset will impact to the load distribution, and so the load on the tire will be different each other. If the load are not same, then the deflection of each tire will be different as well. And it will be the same situation like we are doing lifting with crane on an uncompacted soil. So, and yeah, trust me, it's not good. The capacity of this type of crane also not really huge, about 10 to 100 tons. But some need to be considered to use this crane is its flexibility, suitable for light construction, and can be used for also for material distribution or transport from one place to another, as it has a space for cargo behind here. The second is a crawler crane. I think we all know this type of crane, right? So this type of crane has high stability as its crawler or tracks, giving more contact surface to the ground. It's capable to be operated on a rough area like soft ground, but also we need to do study and decide what treatment does the ground need and what is the requirement. Uh, this type of crane also has huge capacity. The maximum crane capacity that I've ever used in project is about 3,000 ton, if I'm not mistaken. It was a Lamson crane in McDermott. So this crane also has a flexibility in boom length selection, but not as flexible as the telescopic boom. However, you still can choose what length of boom you require in your lifting plan and then assemble them separately. Besides all the pros, this type of crane also has the cons. They are limited mobility and quite long setup time. So yeah, that's for the crawler crane. The next one is rough terrain crane. This type of crane has more flexibility than the all-terrain crane and capable to be operated in challenging areas, and size is more compact. So this crane also equipped with outriggers. So if required, you can use the outriggers to giving more stability in the lifting. Same like the truck mounted crane. The minus is limited in capacity and boom length. The next one is rough no It's a all-terrain crane. We also know this type of crane. This type of crane offering high mobility and rough terrain capacity. As like many truck, this crane can travel in a highway also. And like a rough terrain crane, this crane also can travel on a rough way. This crane now offering a large capacity also. Some of them can reach up to 1,000 tons, and then advanced suspension and steering system for high flexibility also its advantage. But price could be the problem is it's more expensive than the rough terrain crane. Now we get into the conclusion. So this conclusion we use to will telling about how to choose the crane based on that suite with our project. So for truck mounted crane is the best choice if high mobility is needed with medium capacity and ease of use. Crawler cranes suitable for heavy projects in rock or muddy terrain, but always do bearing pressure study before and decide what treatment required for the soil. And rough terrain crane is a solution for rocky and uneven terrain that cannot be used in highways. And if you need a flexibility in lifting operation, you can rely on this crane. All-terrain crane is the option if you want to combine high mobility and capacity, but it will be a little bit pricey. The next one, another type of mobile crane, is the floating crane. This type of crane is a crane that mounted onto a barge or vessel so that you can do a lifting operation on the water. It used water ballasting system as a stability, but we will not discuss about this type of crane in this program. We are still developing detail about this crane, and we will launching it soon in advanced class. The next one is about static crane. First is a tower crane or the hammerhead. Tower crane is a fixed crane used to construct high-rise building and large infrastructure projects. Due to its extended design, this crane has a high lifting capacity and can cover a wide working area. High lifting capacity, it can lift between 10 to 80 tons depending on the model and configuration. Wide reach, the horizontal boom allows the crane to reach a radius 50 to 80 meters, something like that. Adjustable height, it can reach 100 meters or more with a climbing frame system. Space efficient, suitable for dense urban areas as it remains fixed in one location. Stationary operation. Uh, Unlike a mobile crane, a tower crane remains fixed throughout the project. The cons is a long erection and dismantling process, and sometimes it required additional cranes for installation and disassembly. And the other cons is sensitivity to the strong winds. So yeah, stability must be considered to withstand adverse weather condition. Another static crane is laughing tower crane. Unlike the tower crane, which can move the hook position, this laughing tower crane needs to boom up and down to adjust the radius. and it's used in urban projects with limited space and more complex and expensive compared to the hammerhead crane. The next one is a crane's component. First is a component of a crawler crane. In the crawler crane, there is a lattice boom that need to be assembled every time we need to extend or to shorten as required. And also, we can attach the flying jib if required here. Another component is hook here. This is where we attach the load with a set of rigging. And then the next is crawler or track here. This is where the contact area between the crane and the ground underneath. Track sizes are different for each crane, depends on the crane manufacturer and type. So make sure you have this information before doing a lifting plan. Next is we have a counterweight here. This component is important to keep our crane COG in balance positions during the lifting. Some of crane also has an additional counterweight at behind. It is called a super lift counterweight. The purpose is same to keep the crane COG in the balanced position, so that will increase the capacity as well. So yeah, that's for the the main component for the crawler crane. We continue with the rough terrain crane. This will be same as the all-terrain crane. The difference with the all-terrain crane is the number of axle that or tire that we have in the crane. So this type of crane has a telescopic boom here. Uh, Unlike the lattice boom, telescopic boom doesn't need assembly if longer or shorter boom is required. We can simply push the button and then the boom will be automatically extend or shorten based on our requirement. So another component is the outrigger. The outrigger is here. This is the contact area or foundation of the crane to transfer the load to the ground. Some of crane in this type can also stand on its tire during the lifting. So this type of crane also equipped with a counterweight at behind here to make the COG keep in balance position. So that's for a rough terrain crane. We go to quotes and reference. This is the quotes and reference that I use during for in my design, but not limited. You can choose any quotes or reference that suit to your project. So there are three references in here. They are DNV OS H205. It's about lifting operation, and then IMCA M187. This is also about lifting operation, but more like guidelines. Unlike the DNP, DNP is it's a code that we should follow like that. And then the last one is ASME B30.5 about mobile and locomotive cranes. Okay. In this slide, we can see how outriggers load can be changed in mobile crane. The question is, what does make it changing? And the answer is the COG of the crane itself. As we see in this picture that I've taken from a New Zealand standard, if I'm not mistaken, when the load is not attached to the crane, the maximum outrigger forces appear at the behind of the boom, which is fa- which is where the counterweight is located. So when there is no load, the crane COG more affected by the counterweight itself, so that the COG will be at behind the center of the crane. Uh, just for your reference, when I say center of the crane, it means the center of the slew ring or turntable, and that is our reference point to as our origin point to calculate the COG of the crane. Now we continue with the load attached to the crane, as we see in the right column here. The COG, when we put the load to the hook, what's gonna happen if we put the load to the hook? The COG will be started to move to the front of the center. Why? Because the moment force that caused by counterweight is countered by the moment force caused by the load itself. We will see sample of calculation. We will see the detail about this maybe tomorrow, because that's where will I explain about the COG stability and the ground bearing. So yeah. So I hope you all know about what is the formula of moment force in structural analysis. So as we know, they are is load times distance. That means big or small of moment forces will depend on the load and distance, or in this case, we will say it's as a radius of the crane itself. So the longer radius we have, it will create a bigger moment to rotate the crane to the front, while the counterweight gives moment forces uh, to counter the moment forces because of the load. So yeah, that's everything is about the balance on the crane. And the next one is the ground bearing pressure under crawler crane. It also will change depends on the COG location. When there is no load here, the COG will be appear at behind, because the COG only affected by the counterweight at the back. And when there is no when there is a load attached here, the COG move to front, and the same reason, uh, and then the ground bearing pressure also will be started move to the front. So it will be about the balance. So that's all for the part one. So before we get into the crane stability calculation, I will recommend you to understand how to calculate the COG, uh, especially for a crane during lifting, because we will not discuss about this uh, in this program. So basically, it is the same as a structure's COG calculation. We need to know what are the components, what the weight, and where are they located. That's all. And then we combine them together. We by using uh, the formula. If you familiar with this. For example, I'll give the example here. So if we have uh if we have the boom here with the load here, let's say it's a 10 ton, and then we have a counterweight here, 5 tons, and then the distance, this distance we can find it from the manual book of the crane itself. So let's say this is a 2 meters, and then this is a 5 meters. So to find the COG, then we can find it by using this equation, COGX equals to 10 ton times, let's say the center point is at the slew ring. This is X and this is Z. 10 ton times 5 meters times 5 meters, and then minus 5 tons times 2 meters divided by 15 tons. From that, we could get the COG of this system. So it will be, the COG will be 10.10 times 5 minus 5 times 2 divided by 15. So it will be 2.7 meters from the origin point. So it will be, let's say it will be here. This is the COG. So, and then this COG will impact the distribution load to the foundation. In this case, it could be the outriggers or the tracks itself. And if we have the information of the boom weight, for example, we can say it's a let's say it's a 5 ton, for example, and then we should include this 5 ton into this formula to get the combined COG. So yeah, that's how to get the COG of the crane during the lifting. So we need to consider what is the components, what is the weight of each components, and where are they located. That's all. So up until here, is there any question from you?
Do you have any question? Maybe from Muhammad or from Sarma or from Paul? Do you have any
No,
question?
no, no. No, thank you.
So everything's still clear, yeah.
Still okay, yeah?
Yes, clear.
If you have
Yeah.
any question, you just raise your hand and then you can ask directly, and then we can explain to you.
Yeah. So let's continue with the next topic. Uh, the next one is so yeah, we're going to the part 2. So in this part 2, we will discuss about crane stability based on the load capacity. So there are several factors that should be considered to check crane stability based on the load capacity. There are additional loads due to uncertainties in the lifted object's weight and COG. We call it as a gross weight. The next one is crane hook weight. This should be considered if the capacity of the crane in the load chart is gross capacity. Later, we will see what is the gross capacity and what is the net capacity. The next one is a rigging weight. This also needs to be considered as it will give additional load below the hook. And then we have dynamic load. Dynamic load is additional load that caused by external environment like wind, cranes movement, and then hook movement or anything else that could possibly make the object move horizontally or vertically. But we will not discuss about the dynamic load more detail in this class. We will just simply by using the dynamic factor. And if you're interested to learn more about the dynamic, we will open this topic in advanced class. So right now we will discuss about the basic only. The last one is additional load due to multi-crane operation. This we call as skew. Same as the dynamic, there is a factor that we should apply. If we working with the multi cranes arrangement. So in crane capacity, there are two types of capacity that we can see in the load chart. It will depend on the crane's manufacturer. However, it will always mention in the catalog or in the load chart if the capacities shown are net or gross. Now, what is the net capacity of the crane? It is the crane capacities which already consider weight of the hook and ribbing, or we call it part line, while the gross capacity is crane capacities which haven't considered the hook and ribbing weight. So to calculate uh, the hook and ribbing weight and consider it in the load calculation. So, for example, it is shown in this load chart that I took from LTM 1200. This is all terrain type, and I assume the configuration ST or main boom only. So if we look at the node number 4 here, we can see that it is mentioned the hook block and parts are part of the load. So in other words, we can say that the crane capacities in the load chart are gross capacities. Now let's see the load chart. I hope all of you are already familiar on how to read the crane load chart or crane table. As we've seen here, there are many tables that showing the crane capacities in several radius. So before you jump to have a look at the crane table, make sure you have all the information of the crane, uh, like the counterweight configuration here, radius, boom configuration, and is there any jib attached to the boom, and then what is the type of the hook. Is the crane allowed to slewing like here? Because sometimes the crane there is another table from the manufacturer just for a configuration without slewing. So yeah, that's a good thing if you want to increase the capacity, because they will have a different capacities from the slewing itself. So for example, for this type of crane, let's say the counterweight exists right now on the crane is 72 tons here. And in our lifting plan, let's say we need 12-meter radius and 12-meter radius and 40.3 boom length. 40.3 boom length here. And we need to slew the boom. So from this crane table, we will get the capacity of this crane is 42.4. But if slewing the boom is not allowed, possibly we will need a different crane table. So it depends on what the manufacturer says in the manual. So make sure you are familiar with the cranes manual before you use it. No need very detailed, but at least you have reason to choose something from the crane. So yeah, that's the crane LTM. Another example is crane load chart for crawler crane LR11350 by Liebherr. This case, I assume the configuration is SL or main boom only. And this crane capacity is also identified as a gross capacity, as it is mentioned in the note number 4 here. The weight of hook block and parts are part of the load. So to read the table, same as the previous crane, we need to get all information about the crane, uh, like boom configuration, counterweight, hook types, jib if attached, super lift if it's attached, and anything else. And then we can find the capacity based on our requirement. But don't forget to calculate the hook and reeving weight and put into the load calculation. So yeah, that's for the crane table. Now we continue to load to lift. What is load to lift? Load to lift is the preliminary crane load without dynamic loads or skew factors. So it's pure only the object's weight, which in this case is a gross weight, and then we have a rigging weight, and then hook and reeving weight here. So this load we use as a reference during the lifting operation. So we can compare the actual load shown in the crane's monitor and our estimated load in the calculation. And this will be very helpful if we are performing multi-cranes lifting, especially for 3 or more cranes involved. During operation, the the banksman will refer to our load to lift when doing the job. So he will use our load to lift to balance each crane's load from 0% until 100% of estimated load. And it, it will help them to justify if any crane need to be adjusted. So yeah, that's for the load to lift. The formula is gross weight plus rigging weight plus hook and reeving. And then now we go into the gross weight. What is the gross weight? Gross weight is the weight of the load that already considered the contingency and uncertainties of the COG. One of reference that we can use to estimate the gross weight is DNVOS H205 in the section 6.2.1.1 is mentioned. The weight of yard lifted item is often based on calculation only. In such cases, a weight contingency factor 1.1 minimum should be used to define the design weight. So yeah, we can use that 1.1 based on the DNV. Otherwise, we need to have a look another reference that's saying different or for an option, maybe you can refer to ISO. And to simulate the uncertainty of COG, there are two commonly methods that can be used. First is a COG envelope, generally used for operation that involving three or more cranes. And the second is COG factor. I. So this is an example to calculate gross weight, but it's not showing there should so there should be a drawing here. So there, let's say we have a platform size 20 meters, uh, 20 meters by 10 meters. Total weight is 1,000 kilonewton, and we're gonna lift it by utilize four cranes which are located at the corner of the structure. So what is the maximum gross weight of each crane if we're using the COG envelope and COG factor? So yeah, this is the picture. So first we will check the with COG envelope. So to check the COG envelope, we will put the original COG here. This is the original COG and the and it's located 12 meters X and 5 meters Y. So we're gonna put this original COG at the center of a box, which is the size. In this case, I will refer to GNVOS H205 section C200. I have highlighted here. Uh, It is mentioned the size of the envelope is not less than 0.05 from its length, 0.05 from the width, and 0.05 from the height. But in this case, we only use the length and the width since we are not going to check the stability of the object. So we don't need the zero point zero 0.05 from the height. So now we have the size of the box. 0.05 from its length is 1 meter, and 0.05 from its width is half meters. And then we put the box at location where the original COG will be at the center. So it will be half of the length and half of the width of the COG envelope. So this COG will be at the center of this box. The original COG will be at the center of the envelope. And then we put another COGs, and this is imaginary COG at the corner of the box here. These COGs will represent the critical COG position that possibly happen if the objects are tilted or any imposed load from a specific crane during operation. And also these COGs will represent as the critical COG if any modification that should be done on the lifted object. So now we have a 5 potential COG that we should check. First is a original COG, and then COG1, COG2, COG3, and COG4. After that, we continue to get the crane's reaction based on each COG's location. Remember, we now have 5 cases that should be checked here. The net weight here is the crane reaction due to the original COG, and then the case 1 is reaction due to the COG1. Case 2 is reaction due to COG2, and so on. Once we have finished with the crane's reaction for all cases, they all we call as crane's net load. And then we compare all the net load from each cases, and we use the maximum load from particular crane to check its capacity. So we get the maximum by comparing the all cases. For example, from crane 1, the maximum load from all cases is 223.13 kilonewton. And then that is our reference to check capacity of crane 1 by getting the gross load first. So we need to apply the weight contingency factor, which already mentioned before. It's 1.1. So we multiply all the net load with 1.1, and then we get the gross weight here. So yeah, that's the gross weight calculation by using COG envelope. Now, how about the COG, using the COG factor? It is simply just applying a factor to the net load. In this case, I refer to DNV OS H102, which is saying the COG factor 1.05 is normally to be taken. So in this table, it is shown the net weight that is the crane's reaction based on the original COG here. And then to get the gross weight, we just simply multiply with the weight factor 1.1 and COG factor 1.05. So for example, for crane 1, the net weight is the net load is 200 kilonewton. Then we multiply with 1.1 and 1.05, then we get the 231 kilonewton for the gross weight. So yeah, that's how to calculate the gross weight. And then we continue with the hook and reeving. Or sometimes this reeving called as a part line. This weight must be calculated based on the actual condition of its crane. What is the actual hook type? What is the actual boom length? How many part line? What is the working radius? And how high is the boom tip? All these things will impact to the hook and reeving weight. So for the hook weight, we can find it from the catalog or manual book. And to calculate the reeving or part line, we can use this formula, N times Q times H, where N is the numbers of part line attached to the hook. Q is a weight of a single part line per meter length, and H is the maximum length of a part line that measure from a boom tip to the hook. For example, I took from LR 11350 crane this table I've got from the manual book. So yeah, let's say we have a 1,350 tons hook capacity attached currently to the crane, and the rope diameter is 38 millimeter, and and uh, and this crane is going to be used to lift the structure with rigging height 36.71 meters. 36.71 meters, yeah. Lift point distance to the boom of Trax is 2.58 meters, and plus 5 meters, 2.58 plus 5 meters. So it's 7.58 meters, and then with the radius 30 meters and boom length 78 meters, we get the boom type height is 76.61 meters. So I will draw here. So the boom tip height is 76.61. So if this is the boom, this is the boom tip, and then this is the part line. So this is 76.61. Then the part line length is, because this is the rigging and the structure, it's 7.58. This is 7.58. Then the part line length is the boom tip height is minus the total of rigging height and lift point distance to the track. Sorry, 7.58 is up until here, 7.58, and the rigging is 36 point 36.71. 36.71. So the part line length will be 76.61 minus 36.71 minus 7.58. So we got 32.3. 76.61 minus 7.58. 32.3 meters. So once we got the part line length, we now can calculate the total weight of the part line by using the formula N times Q times H, where N is the 32 numbers. That's the because we have a 32 part line attached to the hook, and Q is 5.9 kilograms per meter. That is the mass of single part line, depends on the diameter of the rope. You can find this information from the manual, and usually it is based on the diameter of the rope. And then the H is the length of the part line. So we got the length of the part line is 32.3 meters. So the total mass is about 6,000 98.24 kilograms, or equal to 6.1 ton. And then from the catalog, for the hook weight, we got 40 tons. For the hook mass is 40 tons. That's for 1,350 tons capacity hook. So the total hook and reeving is 46.1 ton. So yeah, that's for the hook and reeving calculation. Uh, is there any question up until here?
Yeah, can you just please tell that how you got this 7661?
76.61.
Yes.
So that's based on the so that based on the radius of and the boom length of this crane. So I think I have something that we can. So yeah,
Okay,
this
fine. Okay, understood.
yeah
Okay, from the range
okay
diagram, you got it. Okay,
yeah.
okay, thank you.
Well, actually, we can find that based on from the
Drawing
outtake.
of the range. Yeah,
Yeah. That's easier to find that
yeah.
from
Easy
the
way is
outtake.
the range diagram. Yeah.
Yes. So yeah, that's for the hook and ribbing. Is there any question?
And regarding the previous slide, you have been showing the case one, case two, case three, right? The
Okay,
example calculation of the
the
COG
COG.
envelope.
Yeah.
Yeah. Regarding this case one, case two, case three, how you have been going with this one, case two, and case three, case four?
So the COG envelope. So the case one is the COG. The case based on the COG one. So the
Okay.
concept is we position the COG not longer in the original position, but we put the COG on the COG one position, which is in the at the corner of the COG envelope, and that is the critical case if we use the COG envelope to use the COG envelope. So that's for example, for the case one, we will put the COG at the COG1 position, and then we calculate the crane reaction based on the COG at the COG1. And then for the case two, it will be based on the COG2, which is in here, the COG
Okay.
at the COG2 position, and so on with the case three and four.
Understood.
Yeah.
Okay. Okay. Thank you.
Yeah, no problem. Any other question?
So where is the where is the calculation for this COG1 and COG2? From where we will get? How
So
we get this load?
so it will be in the load distribution calculation. So we will not discuss about how to distribute the load based on the position of the COG here. So the concept is we will get the crane reaction uh based on the COG position. So that's the concept, using the COG envelope to get the crane reaction. And then once we get all the crane reaction from all cases, then we compare them together and to get the maximum reaction that will be used for the crane check for a specific crane. For example, for the crane one, we find the maximum is at 223.13. That maximum we get by comparing all the cases that we have there. So yeah, that's how to use that. Is that could answer your question, Afef?
My question is how we are getting this value.
Yeah, we will not discuss about it here because it's a part of load distribution class. So when we get into
Okay.
when we get into this class, we hope everybody is already can calculate the load distribution. Is there any other question?
So maybe we have to explain, Nelson, the sequence of basic lifting engineering.
So yeah, I will explain a little bit, but we will not discuss detail about this. So the concept is I for this, I will assume that it's as a rigid structure. So we will calculate it as a determinate structure analysis, where there is no deflection or material properties that should be considered in the calculation. So we will ignore the deflection in this calculation. So first, if let's say, for example, we want to calculate the current reaction based on the original COG. So first, I will distribute the load from the COG from one pair of each side this structure. We can choose either it's this way or this way, right? So to get the first, I will find the crane combined reaction. For let's say it's for this case, I will choose that to be distributed first on this way. So from this side, I will have a system like this. Crane 1-4 at the left and crane 2-3 at the right, and the load will be at here. P is total load. What is the total? 1,000 kilonewton, and the uh the load located is at 12 meters and 8 meters from crane 2-3. From this system, I will get the reaction, combined crane reaction, crane 1-4 and crane 2-3, and then I continue with distribute this load to the crane 1 and crane 4, and this side to the crane 3 and crane 2. So if I look at this side, I will get this system, where which is this is the reaction of crane 1-4, and the crane 1 position at the left hand, and the at the right hand will be crane 4, and the dimension is now 5 meters and 5 meters from crane 4, and then I will get the crane 1 reaction and crane 4 reaction from this combined crane reaction, crane 1-4, like that, and so on with the crane 2 and 3. That's for the original case, or net weight case. And then we will do the same with the case 1, 2, 3, and 4 by put the COG in here at the COG 1, 2, 3, and 4, like that. I hope that answered your question, Afif.
Yeah, I got some out.
Yeah. Any question? So yeah, if there is no any question, we will continue with the next topic. Now we continue with the rigging weight. I think everybody's familiar with this. For example, we have a technical building here, right? And it's going to be lifted from vessel to the yard. And this is the rigging design. Now we are going to calculate the rigging weight. since the COG is at the center of between the lift points, then the rigging design are same for each points. So here I will calculate the rigging weight for one lift points only, and then I will just multiply it with 4. So yeah, this is the total rigging weight. For the shackle weight, you can refer to the catalog. For example, here we have a 200 tons shackle, green pin shackle. Then I will look for its weight in the green pins catalog, like this. For 200-ton shackle, the weight of the shackle is 235 kilograms, or equal to 0.235 tons. And for the sling weight, you also can refer to the catalogs. It depends on sling diameters and what is the material that you use for the sling. Polyester sling usually has a lighter weight than the wire sling. Usually the weight in the catalog shown in as weight per one length unit. So then you can switch the weight based on the length you have in your design. Let's say in this case we have 90 millimeters diameters with 16 meters length. We've got 0.587 tons mass, and then we total them together. We get 1.5194 ton rigging weight for one lifting point, and then we multiply with 4, as we have 4 lift points with the same rigging. Then we get 6.0776 ton for the total rigging weight. I think everybody is familiar with the rigging weight calculation. Or any question about the rigging weight? And then the next is dynamic factor. Dynamic factor is factors that we should apply into our analysis that will represent a dynamic load during lifting. As I have mentioned before, the dynamic loads can be caused by environment condition like wind, wave, and other things that possibly can move the object horizontally or vertically. And then also crane's movement can be should be considered as a dynamic load. And then the elasticity of the crane's boom also can causing to the dynamic impact of the object. The dynamic factor we can refer to DNVO as H2O5 here, table 3.1. If you want to do lifting onshore, like a fabrication yard and construction sites, for example, in condition the crane is not moving, you can use the first column in the table here. But if you want to do lifting on the water, you can choose a dynamic factor in the table 2 and 3 here. Now, what is the difference between inshore and offshore? Inshore is a location that already designed to be protected from high wave, like port or harbor, while offshore is not protected at all. So that's why if we see in the table, the dynamic factor in offshore is bigger than in inshore. Now, what if we are going to do lifting onshore, but the cranes are moving? As we see here in the table notes number 3, it is mentioned we can refer to section 6.2.3.2, which is saying, if you open this section, it is saying that we can use the dynamic factor ensure in table here. So we can choose the dynamic factor ensure. Now we continue to the skew factor. Here we will refer to GNP, and it is mentioned if we use 2 hook lifts in our lifting, we can apply 1.05 skew factor. Or if the lifting involves more than 2 cranes or 2 hooks, you can use 1.1 skew factor. So these skew factors are applied to represent the unbalanced load distribution by the crane. And that could be happen if the actual crane's load during operation is not same as what we have designed. And then the load differences will give impact to the other cranes. It could be higher or lower. So yeah, always remember to include this Q factor if you are working with a multi-crane operation. Now, once we have calculated all the loads from the gross weight of the object, rigging weight, and then the hook and reeving weight, now we can calculate what is the utilization capacity of this crane. This utilization check is to decide if our crane capable or not to do this job by comparing the load and the capacity in percents. For what is the maximum UC that allow for the crane, you can refer to the project or your company requirement. Like in my company here, we are only allowed to use the cranes if the UC maximum 80%, and I think it refers to the ASME or British standard, something like that. I forgot. Now, how to calculate the UC? Basically, it's just load per capacity times 100%. But the load here should be load to lift with the dynamic factor and skew factor if you have cranes arrangement. And the load to lift is gross weight of the object plus rigging and hook and reeving. If we are limited with a UC maximum 80%, then if you find your UC is 90%, that means you cannot use the crane. Or you can use, but some additional requirement need to be fulfilled. Whatever it is, just refer to your project or company regulation. So yeah. Now we continue with this study case. We are going to do lifting for a technical building which has 1,000 kilonewton weight by utilize Liber LR11350 boom configuration SL. That means main boom only. The boom length is 78 meters and the radius is 29 meters. And we are going to find out what is the UC for this crane. First, we will calculate the gross weight of the technical building. Gross weight is net weight times weight factor, which is 1.1 as per DNV, and times COG factor, which is 1.05. Then we got the gross weight is 1,155 kilonewton. And then we continue by calculating the rigging weight. We have calculated the mass before in the here. Yeah, this one. The mass is 6.078 tons. So 6.078 times the gravity, which is 9.81. Then we got the rigging weight is 59.8 kilonewton. And then now we calculate the hook and rigging. Hook mass is 40 tons, as we are using a 1,350 tons hook capacity. Then the mass of hook is weight times gravity, and we got 392.4 kilonewton. Then we calculate the rigging. Since I don't have AutoCAD here, so I will use this crane chart to estimate the part line length. First, we set the chart according to our crane's requirement. Boom length is 78 meter, and the radius is 29 meters. 29 meters, let's say it's here. So by assuming a minimum distance from boom tip to hook is 6 meters. About this, you can refer to the manual book. And so then now we can calculate the boom tip height for 78 meters boom length and 29 meter radius, about 78 meters from ground level. So this is the boom tip now. 6 meters is the clearance to the hook. And then so yeah, this is the boom tip, and then we got 78 from the ground. That's for the boom tip height from the ground level. And then we have rigging plus structure is 32 meters. So rigging plus structure is 32 meters. It will be at here. So the part line will be, so the hook will be here. Then the part line will be here, like that. So now we got the part line length is 78 minus 32 meters here for the rigging and the structure. So we got 46 meters for the part line length. And then the total mass of part line is the numbers of part line 32 here. So the total mass of part line is numbers of part lines 32 times mass of single part line. Mass of single part line is 5.9 kilogram per meter times part line length, which is 46 meters. Then we get total mass of the part line is 8,684.8 kilograms or 8.7 tons. And then we continue to find the weight by multiplying the mass with gravity. Then with the weight of part line is 85.3 kilonewtons here. So we total the hook and the rigging, then we get 477.7 kilonewton for the hook and rigging weight. Yes.
Sorry, I have a question, Nelson.
Yes, Edmond.
Can you please go back to the previous slides?
Yeah.
Thank you. Regarding the total hook and ribbing weight, let's say we
Yeah.
want in the metric ton or tons. Do we need to convert this one, the kilonewtons to tons? Is that okay?
Uh, yeah,
Because
that's okay. Just
usually here we are using the unit
tons.
in
Yeah.
tons. Yes, yes.
Yeah, that's okay. No problem with that because the crane capacity usually in tons. So, because in the at the beginning I calculate the gross weight and the rigging weight in kilonewton. So I will follow the hook and rigging in kilonewton, and after that I will compare one of either it's the weight or the capacity
Yeah,
to kilonewton. And that's okay. It will be the same result for that.
exactly. Thank you so
Yeah,
much. Thank you so much.
no problem. So now we continue uh, with the choosing the dynamic factor that we are going to apply. Since this operation is onshore and the crane is moving, then we can use dynamic factor inshore. And the static hook load is object weight plus the rigging is more than 100 tons but less than 300. Then we will choose the dynamic factor 1.12 here. And then we calculate the load to lift is gross weight plus rigging weight. And yes, Edmund,
I'm sorry to cut you off again,
no
Nelson.
problem.
I'm really sorry. Yeah. I'm a bit confused about insurance. So what do you mean by moving cranes onshore?
The moving cranes means the cranes, the track is moving. So the crane itself moving from one place to another place like that.
You mean it's just sitting to another
And
locations?
uh,
Sitting from one
not
place to another place or another
uh,
locations?
sorry. The moving cranes, not moving cranes actually. It's a moving object. So we will consider it as a moving cranes and slewing also. So the during its slewing, it will create dynamic forces to the object, the lifted object and the crane itself. So yeah, it's we can say that it's moving objects, not the moving and moving cranes. So the dynamic on
Means moving load, right?
yes, correct.
Sorry, Mr. Nelson, but you have to consider only DAF onshore. If only inshore is available, inshore you have to applicable if the crane we are going to use in the sheltered water or in the jetty.
No, if you open that's what I have explained previously. If you uh
Okay. First, actually, as of now, there is no DNV OS H205. Okay, that is being superseded. Still, okay, we will apply those definitions as per that is same in the new latest document also. But
mhm.
inshore is applicable only when the crane is going to be used in the jetty or in the
No.
sheltered waters.
No, if you open this section 6.2.3.2, it will be saying that if the moving cranes onshore will refers to the dynamic DIF inshore. Anyways, it's just
Anyway,
a
we will
dynamic.
verify it. That's not a problem. Okay, I will go with you. Okay, but
Yeah,
as per the latest edition, as per the DNVSTN 001, I
yeah,
don't think inshore will be applicable.
yeah. Anyway, it's a dynamic factor. We can follow
Yeah,
anything.
dynamic
Yeah,
factory I will follow. That's
yeah.
fine.
Yeah. As long as
Mhm.
we apply the dynamic factor, it will be
That's
okay.
correct. Yeah, that's correct.
Yes,
Agreed.
yes.
Agreed.
So Edmund, I think it could answer the your question. Yeah,
Yep, yeah. Thank you so much. Thank you
no
for.
problem. Yeah, yes.
Thank you.
So the load to lift now is gross weight plus rigging and hook and rigging. So we have now we get the load to lift is 1,692.5 kilonewton. So that's for the load to lift. And then now we check the crane capacity here in the crane table. But unfortunately, there is no capacity for radius 29 meters. So for this case, I will use interpolation to get the capacity. For radius 28, we get 213 tons capacity here. And for radius 30 meters, we get 194 ton capacity. By interpolate them, we get a 203.5 tons for 28-meter radius. But we need to make sure that the cranes manufacturer allow us to interpolate the capacity, and in this case, because I'm using the lever, and if we compare with the Licon software, they for 29 meters we get the same capacity for this configuration. So I will saying that it's is green light to interpolate the capacity based on Liber manual. So and now we calculate the utilization load to lift times dynamic factor times skew factor, but we don't use it as we only use a single crane divided by crane capacity times 100%, and we get 94.95% utilization. And now it depends on your regulation if it's a go or no go lift to lift it with the UC. But I will tell you if it's in here more than 80%, then it's a no go for the lifting. So yeah, that's for the crane load stability. Is there any question about this topic? So yeah, that's the topic for today. If you have any questions, you can raise your hand or asking. I hope what I explained today is very clear to you. So if there is no misinterpret or understanding.
Yeah, misunderstanding is big problem, right, Nelson? So
Yeah.
No, it's okay. It's okay. Dian and Nelson. It's an excellent, discussion. Very informative. Yeah.
Yeah. Thanks, Paul.
thank you, Paul. So any question from you, Muhammad? Do you wanna ask something?
This recording material you will send to mail?
Yes. I will send you our recording after tomorrow. So I will directly send it day 1 and day 2 for recording. So you can use our recording to finish your capstone.
Okay.
So is there any question from all of you?
What is the meaning of
Sorry,
hello?
capstone?
Capstone project we have to do after 2 days or how?
No, capstone project. Capstone project you can finish. We give you duration for 1 month. So you can finish your capstone project for 1 month, and then we can give it to you certificate of achievement, and then we attach your capstone at your certificate, and we will upload to our website. So with QR code, so anybody can scan your certificate and they can show your capstone attach in your certificate. But if you not finish your capstone, we give it to you certificate, but only certificate of attendance, because you're not doing any your capstone. But don't worry, we're not asking you have to finish your capstone and correctly 100%. No, you just finish, you just do it your capstone, and then you can submit to us, to Nelson directly. And if there is something wrong, we can give you advice. So mostly our participant, they will really understand about this class, about their program during the capstone, because during the capstone you have discussion with Nelson directly about your capstone. Maybe now in during this class, a little bit like confused, but I believe that when you finish your capstone, when you start to do your capstone, you will understand more about the class.
Okay.
Like this. So 1 month, you can finish your capstone in 1 month. If in 1 month you cannot finish your capstone, you can send message to Nelson, and you ask for extend the time.
Okay.
Okay, Mohammed. So do you have any question? How many questions, Nelson, for this project? I think the 2, right?
No, it's only
Only
one.
Only
Yeah,
one.
yeah.
Because we have
And it's not a question, it's a
a project.
real case, yeah. Real
Yes,
case.
it's real case. So
Yeah.
that's why we call this program Upskilling Program, because we are not giving to you a question, but this is really a study case for you. And our capstone is a real study case from site. So this is real case from site.
Okay.
Is there any question regarding the capstone?
No.
No? So I give it to you back, Nelson.
Yeah, so yeah, I think that's all for today. It's about the crane load stability, and tomorrow we will continue with the COG stability of the crane. For the COG stability, we will discuss about 2 cranes only. They are cranes with outriggers, and the second is with the tracks. So yeah. And also we will discuss about the ground bearing pressure for those 2 kind of cranes. So yeah, that's for tomorrow. So
Tomorrow we
yeah,
will continue our class for crane stability and ground bearing pressure for mobile crane. Outrigger, outrigger, and
yeah,
also crawler.
yes,
Yeah,
correct.
also crawler. So tomorrow we will start to calculate about ground bearing pressure, crane stability for outrigger and crawler crane. So
Yeah, it's not really complicated, but the one we will discuss is just about the basic to understand how the load will be distributed to the ground underneath. So yeah, just simple basic like that.
So on for the capstone project, so we have to do the crane selection, and from you will be giving the list of the cranes on the load charts, or how it will be, because I've seen that PowerPoint with only with the load drawing is available as of now.
Yes, so I expect that the crane data will be from your side, but if you don't have any crane data at the moment, you can ask me some
Okay,
of them, so I will prepare the crane data for you.
fine. Okay,
Yes,
thank you.
no problem.
Thank you.
So yeah, that's for today. I will give the class back to you, Miss Dian.
Okay, thank you so much, Nelson, for your for our class today, and also for our participant to join with our upskilling program. So this is the difference between training and our program. Our program is more about the study case and small project. We call it the capstone project, and we are not focused with your certification, and then we are not focused with your grade. The one things that we focus is your qualification. So we hope that after this class you will be more qualified for your job. And then we are not asking you have to finish your capstone and correctly 100% correct. No, we only ask you to finish your capstone, and that's fine. If you did wrong, that's fine. And then we can help you to make correct your capstone. And then during that period, you can ask with Nelson directly, or also your case from site. So here we are not only teach you, but we guide you to understand more about mobile crane stability or other topic that you wanna join after this. So we guide you to understand. So it's not only about training, but it's more about upskilling your. So we want to upskill your skill, so to make you qualified and more understand about your job on site. Because our goals is safe lifting operation, yeah, and then we don't like if someone lost their life because we don't know what we have to do on site. So that's why we create this program. It's quite tired because we have a lot of students. They take a lot of class, and also they are doing a lot of capstone. But this is if you want to become qualified, so this is the journey you have to follow. You cannot just sit down in classroom and then read a lot of theory, and after that you have to finish multiple choice. No, we have to do like this, like a two-way learning, and then we give it to you study case, we give it to you capstone related to the case study on site. Hopefully you can use the capstone project as your resume, because this is really like a project, mini project for you. And by the time you will learn more, during that period you will learn more and more. So it's more about qualification, it's not about the certification. So it's like this, it's like that, yeah, Nelson, yeah. So next month we have a fundamental of heavy transport. So you will learn about stability, lasting calculation for SPMT and modular conventional trailer. So it's all about transportation, heavy transport. So now we're talking about heavy lifting operation, and then next month we will start to talk about heavy transport operation. So how you calculate the stability for trailer for SPMT, and also how you calculate about maneuver and also lasting for SPMT, operation for your SPMT, something like that. So here we are. We can say that FDP Consulting is your cheerleaders, yeah, cheerleaders for your dream. So Nelson as a technical advisor for engineering, and we have also other speaker for technical advisor for heavy transport and also for heavy maintenance. So all of us are willing to support you to be qualified, but if you don't use the tools that we give it to you, so you cannot be qualified. What is the tools? Our WhatsApp group, our study case, our recording class, our capstone project, all of these the tools that we provide for you to make you qualified and understand more about the topic that you take it, something like that. So thank you so much.
Sorry, just to have one word. Mr. Nelson, just I'm sharing my screen. Don't this thing regarding the inshore and onshore and offshore.
Yes,
Okay.
yes.
Yeah, don't this thing. Just it's a two-way as you told. Okay. Hope you can see the screen, right?
Yeah.
Okay. See, extract from DNVOHS. Okay.
Yeah.
Yeah. You can see the screen, correct? Extract.
Mm-hmm.
You can see my screen now, right?
Huh?
You can see my screen?
No, no,
No,
no.
no, no.
Can you allow me to share the screen? Yeah,
Uh,
hope now we can see the screen.
yes.
Yes.
Yeah.
Okay. See, dynamic amplification factor.
Uh-huh.
Okay, 3.2.2.1 and 3.2.2.4. Okay, onshore quay and yard crane lifts to and from barge or move along quay, and
Uh-huh.
inshore lift with crane vessel from or to barge or ship in sheltered waters.
Yeah.
So we have to go with onshore DAF. If we can go with the inshore DAF, to my understanding, where we may have to go with the higher capacity of the crane.
Can you open
Marginally.
can you open
Marginally.
section 6.2?
Oh yeah, no matter. Yeah, 6 point.
Point
See,
two
this is the one,
point
6.2.3. Okay,
yeah.
6.2.3.1 will refer
Yeah.
to the table 3.1 related to the dynamic effects for onshore lift. And 6.2.3.2 for crawler cranes traveling with load, possible dynamic effects should be evaluated thoroughly, crane speeds. And again, we have to go with inshore lift. Only for the crawler cranes, if it is been traveling with load, where the
Yeah.
crawler crane has been stationary and it is not going to travel, then still we can apply onshore DAF. Okay, if it is going to travel with load, then only we have to go with the inshore DAF.
So you're saying slewing is not traveling with loads?
No,
No?
no. Traveling literally, the crawler crane has to move from one position to another position by crawling.
Well, what my understanding is that the load is moving, so that will
Yeah,
impact to
because
the
the slewing is a slewing cannot be moving. See, in that case, then I'm not sure about it because usually the moving will be with the traveling. That's what if you go with that one, 6 point. Um, uh, 6 point. Sorry, load, special load. See, crawler trains traveling with load. They are not drilling, slewing with load. Traveling is a clear indication here. Okay, then we have to go with inshore lifts.
All right.
Maybe
That's
it's a two-way. Okay, maybe my interpretation might be the different.
no,
So
no,
just
no, no.
to confirm. Okay.
That's good. That's
Okay.
a good communication.
Yeah.
Yeah,
Well,
that's good
yeah.
communication, Sarma.
Thanks,
Okay.
thanks, Sarma. That's
Okay.
because before my I'm thinking that
Yeah,
the
see, it is good.
slewing.
See, as good as if you have been using 1.12, that is
Yeah.
much better than 1.10 for sure.
Yeah,
Okay, but the thing is, again, in certain cases where the smaller loads, where if you are having good capacity of trains like McDermott, you might not have a problem.
It's more
But when you are
safe,
coming
right?
with a small project, huh?
It's more safe also.
Yeah, that's why.
Yeah.
If the company is like big McDermott, where Mr. Nelson had worked, that might not be a problem. But when working with the smaller cranes, it might be going for the problem because
Yeah,
this 2% will go. Maybe that it goes for a complex to complicated to complex lift. The lift
and they
category
don't
will
like.
change from routine to speed.
Yeah, and
Yeah,
they
they
don't
don't
like
like,
to hire bigger crane,
yes,
right?
higher capacity crane. Yes,
Yeah, we
exactly.
says, oh, no, no, no. Think
Exactly.
about cost. Think about cost, right?
Yeah,
It's
Reduce.
about
Yeah,
efficiency. Yeah.
it's all
efficiency.
about
Yes,
Yeah.
efficiency.
efficiency.
Yeah, but
Yes. Thank you.
thanks, Sarma. Thanks.
Yeah, thank you.
Thanks for the input. Yeah, that's
Thank you.
good.
Thank you, sir. Thank you.
That's the engineering
Yeah, sure.
engineering
That's
point of
what.
view, right?
Engineering
Yes, yes,
always go up, Sarma. So
yes,
it's
yes,
always
yes.
safe,
Thank you.
and then
Yeah.
operation is always play down.
Yes, exactly.
Right? So that's why engineering and operation they are never best friend together.
Yes, exactly.
including
So same,
including HEC.
including SSC, they never be
Because I'm
best
a
friend.
No,
Never.
yeah,
no,
because I'm
Yeah,
HEC guy,
no,
yeah.
yeah,
but
because
Yeah.
actually, they should work together, not working
Exactly.
separately. As a
yeah.
that's
Yeah.
the switch perception from the previous to now condition. That's really sad to hear about that actually, but that's the reality that we have right now,
But
and
this
Yeah, there is a ch
that's
yeah,
our problem right now. So
that's the challenge for us
yeah,
to
that's a challenge for now.
bring back the perception that we are working together as a team, right?
yeah,
So
sure.
yeah,
Our KPI is the same, right? Our KPI is safe lifting operation. So sometimes like
Yes.
if something happened with operation, so operation team will blame us as an engineering team or will blame SSG. But if doing well, so operation will get the name, right?
yeah.
They forget about the engineering, they forget about SSG, operation will get the name. So um, here we are now try to bring back all together all the perception like okay, if you wanna do something like that, see against a little bit from engineering perspective. So we have what we have to do to keep our operations safe. We have to ask to our management like that because if something happened during the operation, so there are so many hidden costs can be happen, including brand for the company. And not only brand for the company, also
It's an
brand
indirect cost, reputation. That is
reputation.
most important
Reputation
thing.
is
Yes,
the
yes,
Yeah.
asset for the company. And
yes,
also
yes,
reputation is your asset as a person.
yes, yes.
So if
And
something
individual
happened
moral is
during
there.
your operation, so people will ask, who is
Yes,
supervise this operation? And then someone said, Mr. Sarma. So this is related to your reputation as well. So it's not
yes,
only reputation for the company, but also reputation for us as a subject matter expert in
yes.
charge and that operation. So we have to be careful with all of that. So we have to be careful when we say yes to our management, because if something happened with this operation, they will blame us, right?
Yes,
Can I add something here? In addition to that, it's not only about blaming, but it's a blaming culture sometimes, most of the time.
Yeah.
But imagine the accountability and responsibility here.
Yes.
So imagine if something goes wrong, it's, 100% the in charge or the responsible person might go to jail, especially if
yes,
there'll be fatality. So, some people they'll say, pointing fingers to this guy, to other guy because they don't want to be on their shoulder. They
Yeah.
Right.
want only to blame someone else.
Yes. Yes. That's true. So that's why we have to be careful with that, right?
yeah.
Yeah,
Think about
we
reputation.
learn.
Because,
Yeah, we will learn a lot here
yeah,
along the way. With your help, Dian and Nelson as well. Yeah.
yeah, because
Yeah.
reputation is everything. Yeah, also for the company, everything. If you lost your business because you don't have a lot of money, you can go to the bank and
Yes,
ask. As long as you always play safe, I believe that bank will give it to you some loan to recover your
Yeah.
capital. But
Correct.
if your reputation lost,
Yeah.
nobody will trust you anymore. So we have to
And
be careful with reputation.
correct. That there will be legal arguments, financial arguments.
Mm,
Let's say you have the number of incidents, and
mm.
then your insurance premium will be increased. So it's not only about reputation; it's also about financial and legal arguments.
Yes.
At the same time, moral
Mm.
as well.
Yes, hidden
Mm.
hidden costs. There are so
Yeah,
many costs,
yes,
exactly.
hidden costs. So if your management, Sarma, for example, if your management always complain to you, you start to speak about hidden costs and explain to them. Hopefully, they
Yeah,
will understand about that.
yeah, troublemaker. Yeah,
Yeah,
HSC, troublemaker, safety troublemaker.
yeah, yeah. That's true. That's true. Like because I believe that not so many company aware about hidden costs.
Exactly. Yeah.
Productivity loss, they don't know about this productivity loss. They don't know
Yep.
about the reputation. They don't know about additional costs like a shutdown equipment,
Yep.
productivity loss for the employee. So how
Yep.
many wasting money like this, wasting money, wasting time, lost the brand. So productivity loss from both sides, yeah, from equipment standby,
Yeah.
yes,
employee standby. So it's a lot only because we don't care about safety. like this.
Exactly.
Yeah, so
Production over safety, operation over safety. Yeah.
yeah,
Yeah,
yes,
yeah.
yes. At the end, this is and at the end we call this lifting management system, and then Lean Six Sigma for lifting operation. So we talk about that Lean Six Sigma. So how we can do some, for example, analysis
Yeah.
to be able to analyze wasting money. So we try to eliminate wasting costs without eliminate safety. So that's
Exactly.
called Lean Six Sigma for the lifting operation. So at the end, we don't need to cut safety to make our operation efficient. We don't need to do this. We can run Lean Six Sigma to analyze all of this, and then we can find where is the cost that we have to eliminate to make our operation more effective and efficient without ignore safety.
Yeah, that should be the goal.
Absolutely.
Yeah, this is for the management. I think that this is management. This decision maker have to understand about this, so they are not only think like, oh, we have to use. We don't need to do any 6 monthly inspection. Annual inspection is enough. Just wasting time, wasting money. All is just trouble. No. If we can explain to them, they will understand why we have to do all of this like this. Anyway, thank you so much.
Thank you.
Thank you so much, gentlemen, because there is only me woman here, so I can call gentlemen.
Yeah, understood. Already got a call.
Yeah, so thank you so much, my friend. Thank you so much to be part of our upskilling program. Hopefully, you enjoy our program today. You get some knowledge from our class today. So tomorrow we will continue about crane stability and also ground bearing pressure. And tomorrow we will explain a little bit about our capstone. And then recording, I will send it to you tomorrow after our class finish. I will send it to you by email. So thank you so much. Have a good night for all of you. And Nelson, thank you so much also for your time to deliver your knowledge to all of us. We really appreciate that. So thank you, everyone. Have a good night. Yeah, have a good sleep.